Okay, listen. Now, we saw resource means time, memory. We saw size of the instance is basically n. Okay. Now, let's try to analyze the definition of theoretical or mathematical or priori approach. Now, we'll read it together in a chorus. Where I stop reading, उसके आगे से तुमको read करना है. Okay. This approach mathematically determines
the quantity of resources required by each algorithm as a function of size of instance.
Now you will read this definition once again, okay? But before we do that, what we will do is we'll eliminate one of these two factors. We'll eliminate one of these two factors. Now, what do you think in today's world? What is more important, time or memory? Time. So in today's world, we don't mind spending a little more money on memory if we get a faster execution speed. So here onwards, whenever we say resource would mean time, execution time. Okay. So one thing which you should remember now onwards, and that is here onwards, complexity would mean same as efficiency, which would mean same as what?
Execution time.
So whenever somebody says complexity, efficiency, execution time, it means one and the
same.
Do you agree with me?
Yes.
Alright. What we'll do is just we'll write this statement and then we'll go back to that definition again. Next paragraph. Right. Since execution time is more important than memory space, here onwards, copy this, complexity same as efficiency, same as execution time. Listen. Now what we will do is, we will now discuss that definition again. We will read out that definition of mathematical approach again. Instead of resource, you will now say time, and instead of size of the instance, you will say n. Okay. Now read it very carefully. Come on. This approach
mathematically determines the quantity of time required by each algorithm as a function of n.
As a function of
n.
Now listen to me very carefully. Slowly, we are moving towards important topic. Now what that definition says is that this approach mathematically determines the quantity of time required by each algorithm as a function of n. Now, we say this function of n. When we say function of n, how do we write it?
F of n.
These three words, function of n. How do we write it?
F of n.
So I will say complexity or execution time or efficiency is equal to f of n. Now this expression which you see over here in this box, this expression, this is the most important expression of the entire syllabus. The entire subject stands on this expression. Entire subject, this is the foundation of the subject. That execution time is actually a function of n. Now what exactly this means, that you will come to know after 10-15 minutes. Right now, I will just tell you, I'll just try to explain you how come execution time is a function of n. Actually, this expression has two meanings. How many?
Two.
One of its meanings I will explain you right now. See, one meaning of this expression is that the execution time is dependent on n. The more the value of n, the more will be the time taken by the program. By the way, what is n? Tell me in English, like what is n?
Number of elements.
Right. So to explain my point, I will take a very simple example. Let's say we are writing a program to display numbers from 1 to n. We are writing a program to display numbers from where to where? 1 to n. So for that, I will write a very simple for loop. For I equal to 1, I less than equal to n, I plus plus, printf, %d, I. This I will be the input which user is going to give us. Sorry, n is the input which user will give us. Simple question. If n is equal to 10, how many times the printf will execute? 10 times. If n is equal to 1000, how many times printf will execute?
1000.
So this program will take more time when n is equal to 10 or n is equal to 1000?
1000.
Obviously. So that means the execution time is directly dependent on n. It is a function of n. The function of n means this concept. The more the value of n, the more is the execution time. Do you understand that? Now there is one more meaning to that term function of n, which we'll see very shortly, but we'll write a little first. Right. Since resource means execution time, the definition of priori approach can be written as now I suggest you copy this box in a different ink, this entire box. I write it in a different ink. Okay. Alright. Now we'll try to understand this better. The discussion for the next 10-15 minutes might be confusing for you. So if you are getting confused, that means you are paying attention. And all your confusion will go away after 15 minutes. Okay, so you have to be very attentive. Alright. Now, once you write this, let's consider an algorithm. For whom f of n is equal to 0.38 seconds, where n is equal to 10,000. I repeat, there is an algorithm for whom f of n is equal to this, for n is equal to 10,000. Now tell me what is f of n? Tell me in English like words. No. What does it mean? Efficiency. Execution time. So here onwards you might as well call it execution time. So what this line means, you should read it this way. The execution time taken by an algorithm is 0.38 seconds when n is equal to 10,000. Do you understand that?
Yes, sir.
Okay, now be very attentive. Things are going to be a little confusing. Now let's say there are two different computers. A and B. When you execute that algorithm, that program on computer A, it takes 0.38 seconds to execute. Now let's say there is one more computer which is slower than computer A, slower in speed. That means its processor is outdated, its operating system is outdated. Okay, all in all, its configuration is much lesser than A. When you execute the same algorithm on computer B for the same value of n, same algorithm, same value of n on computer B, will it execute faster or slower on computer B?
Slower.
Definitely slower, because here the hardware, the machine itself is slower. Do you understand this? So what is happening over here? The efficiency of algorithm, can you complete my statement?
Depends on the
Very good. Depends on the hardware of the machine. Machine means computer, hardware means processor, memory, and so on. So I will say that the efficiency of the algorithm is machine dependent. What did I say? Is
machine dependent.
in the world of software, there is a belief, there is a philosophy, and that philosophy is the efficiency of a software, the performance of a software must be machine independent. I repeat myself, there is a philosophy, there is a belief that the efficiency, the performance of the software must be machine independent, which is not happening over here. Be attentive, things are going to be confusing but very interesting. Now the question is, why is the efficiency machine dependent in this situation? So now I'll answer that question. Why it is machine dependent? The efficiency is machine dependent because in this situation we are measuring the execution time in units of time. I repeat, the efficiency is machine dependent because we are measuring the execution time in units of time. Let me just explain. Second, minute, hours, all these are
Units of time.
So what I said is the efficiency is machine dependent because we are because we are measuring the execution time in
Units
of time. That's what I said. If you are paying attention, you should immediately tell me something.
What is the other method?
Very good, very good. Understand what she said. See, you are not going to measure execution time in kilograms. Do you understand what I am saying?
Yes.
You are not going to measure execution time in kilometers. You are bound to measure execution time in
Second.
units of time. It could be minutes, hours, but basically unit of time. So the moment I said that, you should have told me that we will measure execution time in units of time. What is the other way, as she said? What is the other way of measuring? Did you understand that much? Sure.
Yes, sir.
So the other way is, don't measure execution time in units of time. Measure execution time using the concept of what did I write over here?
Critical operation.
Critical operation. Ask me a question.
What
What
is
is
critical
critical
operation?
Alright, now let's write a little and then I'll explain you that. Right. Consider an algorithm whose efficiency is copy this statement. This one. Right, next line. In this situation, the efficiency of the algorithm is machine dependent. Full stop. This is because we are measuring execution time in units of time. So, to make it machine independent, we should measure efficiency using the concept of critical operation. Okay, now we need to understand what is a critical operation. So next paragraph, let's write its definition right. A critical operation is any operation which takes significant amount of time. Alright. Now, let's try to understand what this critical operation is with the help of a code. So look over here. While I write the code, you try to see how it works. For I equal to 1, I less than equal to n, I plus plus. For j equal to 1, j less than equal to n, j plus plus. Then I write printf %d, or let me write simply printf AoA, analysis of algorithm. Okay. Sorry. Now be very attentive, things are interesting and difficult. Now let's say somebody is telling you to analyze this code. By the way, what is the meaning of analyzing this code? Finding the complexity. Alright. Now one way of finding the complexity is that you measure the execution time in units of time. But that is not what we aim for. We want to use the concept of critical operation. Alright. Now to understand the concept of critical operation, let's say we are in let's say this initialization takes 10 raised to minus 9 seconds to execute within the processor. See, what I mean is very simple. Whenever you execute any program, every operation in that program will require some amount of time to execute in the processor. Okay, that time could be as little as 10 raised to minus 9 seconds. But sometime it will require, it cannot be 0. You understood what I am saying? So let's say every initialization requires 10 raised to minus 9 seconds to execute within the processor. That way, let's say the condition requires 10 raised to minus 8 seconds to execute within the processor. and let's say the alteration requires 10 raised to minus 7 seconds and printf requires 10 raised to minus 2 seconds to execute within the processor. Do you understand that? Now what is the amount of time taken by printf?
10 raised to minus 2.
Tell me one thing, 10 raised to minus 2 seconds, this amount of time is negligible or substantial for a human being? Negligible, you cannot perceive it, right? But be attentive. This is a subject of relativity. Now what I mean by relativity, be attentive. Now when you compare the time taken by printf with the time taken by initialization, then the time taken by printf is very large or negligible. I repeat myself, my question is very simple. When you compare the time taken by printf, compare this time with the time taken by the initialization. After doing the comparison, the time taken by printf is very large or negligible. Very large. Okay, just do division 10 raised to minus 2 upon 10 raised to minus 9. How much it is? 10 raised to 7. 10 raised to 7 is such a large number. Do you understand what I am saying? You see things in comparison. Similarly, when you compare this and this, it is 10 raised to 6. 10 raised to 5. So the point I am trying to make is the time taken by printf is much more, complete my statement, than the time taken by other operations. Am I right? So I will now say that this printf takes significant amount of time. Printf takes, what did I say?
Significant amount of time.
Okay. Now when we use that word significant, we mean significant when compared to others. So when compared to other operations of this code, printf takes significant amount of time. Do you understand that? Now let's read the definition of critical operation once again.
Critical operation is any operation which takes significant amount of time.
So listen, be attentive. Somebody has told you, be attentive, somebody has told you that analyze this code. Now if you want to analyze any code, you should do it in 2 steps. How many steps?
2 steps.
Horribly important. Now what I will do is, I will make you write these 2 steps at the top of your notebook where we normally write what? Golden rule. So what you do is, the page on which you are writing, over here, just you are writing golden rule and write over there. थोड़ा छोटा लिखना, write small. Golden rule, right. Use the following 2 steps. Use the following 2 steps to find complexity. To find complexity. Number 1, next line, number 1. Decide who the hell is the critical operation. Who is like that? Is the critical operation. Number 2, count how many times the critical operation executes in terms of n.